Hello and welcome to my channel. In this video I will show you how to make this. So this is an LM8UU linear bearing replacement. So why would you need one? I'm planning to use this on my new 3D printer that I built. I want to replace the steel ball bearings with something, some material that is softer. My problem is that I couldn't find hardened steel rods for the X-axis on my printer, so I bought some steel rods which are much softer, and the steel bearings are making some grooves in it. It doesn't work very well, so I will experiment with 3D printed plastic bearings. I have experience with this already on some other materials like carbon rods, and those work very well, so I think this will work. Time will tell how durable they are, but that's why I'm doing this. So in order to start modeling, you will need some reference image. I made a Google image search for LM8UU dimensions and I found this image. I will use this as a reference. Let's save the project first. Click save, type some name. I will call it LM8UU. Save. Create a new sketch by hitting the create sketch icon. Assign it to the XY plane. Let's create a circle for the inner diameter, which is 8.38 millimeters. Let's create another one for the outer diameter, which is 14.99. Okay, let's zoom in. I use my mouse wheel here and I pan with a touchpad. If you don't have a touchpad, you can use the pen tool here. Okay, so we will use the offset tool for the grooves. Let's put minus 0.8, so I don't have a reference for this, how deep they are, but let's try this. Now we will need the sliding surfaces, so there will be some shapes here, but we also need some distance from the grooves, so I will add another offset from the outer diameter. You will understand in a sec why, which could be minus 1.5 millimeters. Okay, and then let's make these sliding surfaces. First I will add a line from the center. The length of the line doesn't really matter, it just has to be longer than so it should go out from the bearing. I've used 20 millimeters. I hit tab for the degrees. I will type 30 degrees here. You can experiment with different angles. I just found this good enough, so I will add another one and do the same but downwards. So it's 20 millimeters and 30 degrees downward. So now I have these two lines here. And I will make a circular pattern, so I want to have this as the sliding surface. So if I click this, okay, I will create a circular pattern. Next, circular pattern, select objects, hit the first and shift click on the second one, so 2 is selected. Now select the center point, click on the center, and I want 5 of these. So 6 is not a good number because it will overlap completely, and I need these gaps in between, so I will use 5. Okay, and now I can finish my sketch here. I have everything what I need for the extrusion part. So the next part is the extrusion. I will select everything for the outer diameter, hit E for extrusion, click on the first shape, second, and so on, so all the way all around. Okay, and same thing with the next circle. So this one that I'm selecting now, this will be in between the notches and the inner sliding surfaces. So now I select these ones. So I'm shift clicking all the time, and now I have the profile of the bearing, and I will just rotate this so you can see better. Escape for stopping the rotation, and the length of the bearing is 23.95, so 23.95 millimeters. Okay, so we have the rough shape now. I will rename the new body to LM8UU. LM8UU. Okay, and I will hide it, and I come back to my sketch, but I don't edit the sketch, I just select make it visible. So next I will do the notches. Okay, so the total length is 23.95. We destruct 15.25 from this, and we divide by 2. Then we get the distance of the groove from both ends, so it's 4.35. So I will create offset plane. Okay, I put back the body, and I want the offset from the object, top of the object, so I select the top and go down 4.35, and it's minus, of course. So this is our top offset plane where the groove will be, and I rotate this a little bit so we can see the bottom. Now I will construct another offset plane from the object. Oh, let's hide the sketch a little bit. So from the object, and we will go up, so it's minus 4.35. Okay, so we have the two offset planes. Let's rotate this back a little bit. Okay, now let's hide the body and get back to the sketch, and the groove will be this outer part here. So we will make a new extrusion, and we will cut with this. So select again the whole outer part here. Okay, the construction plane are in the way. So I'm shift clicking again these shapes here. Okay, so this is what I want to cut. I put back the construction plane and the object, and we will start from the construction plane. So start from object and select the plane, and I will do a symmetric cut, and then how wide it should be, so let it be 0.5 millimeters first, and we will add some chamfers later. So this is 0.5 millimeters, and it should be cut. Okay, done. Now we will add another extrusion, so let's hide it again in the constructions plane. So extrude, do the same thing, so we select our cutting tool here basically. Let's put back the object and the construction planes, and we will start from this object now here, which is this plane. We will do a symmetric 0.5. There you go. So if I hide now the construction plane and the sketch, you can see the grooves are cut out. Okay, next we will add some chamfers to these cutouts. So I select the circles on the body. I'm just shift clicking again, modify, and select chamfer. And the distance we will put 0.3 millimeters maybe. Okay, that's nice. Now we will add some chamfers also for the top and bottom of the thing. So we will select these edges here. It may be a little bit difficult for the selecting the small ones. You can zoom in for better resolution. Again, shift clicking all these. Okay, and then modify and use the chamfer, and we will put a relatively big number here, so maybe 1 millimeter. Nice. Okay, and we will do the same for the bottom. So I use this orbit tool to rotate the object and just select again by shift clicking. Okay, modify, chamfer, 20 selected, just like before, and let's put 1 millimeter here. Okay, now let's use the orbit tool to look around that everything is nice and clean. Let's zoom out a little bit, and I also will add some fillets on these circles here. So fillet, and that could be 0.5 millimeters maybe. All right. Okay. So basically that's it. We have now our LM8UU replacement bearing. We can export this as an STL and then print it with a 3D printer. Once we printed it, we can try it with the actual steel rod, and we can feel how well it slides. And if we need to adjust, we can always come back to the sketch, right click and edit sketch, and we can change the dimensions here for inner diameter and so on. So we can make it this bigger, smaller, and then these cutouts will be the same. Okay, so yeah. And how to export this as an STL? So select the object from the browser, right click and save as STL.